We're going to take a look at our first multivariable limit problem. Let's evaluate the limit as xy approaches 2, 8 of the function 3x squared times y plus the square root of x times y. Before we actually begin this solution, let's take a look at the behavior of this function at this input point. If you evaluated x equal 2 and y equal 8, you might say to yourself, 2 squared is 4, times 8 is 32, times 3 is 96, and then 2 times 8 is 16, square root of 16 is 4 plus 96 is 100. There's no problem with the actual evaluation, and later in this lesson we're going to call this continuity. Remember that a lot of times limits are subtle when the function is not very well defined at the limiting constant point in the domain. Because we see that that's not the case in this situation, we might imagine that we could apply limit laws. Here we have a constant multiple, here we have a power, here we have a y, here we have an x. We just saw in the last video a bunch of different tools and rules that we could use to bring this limit down to the basics. Let's try that. We have now just kind of guessed that this limit should exist, and let's see if we can apply our limit laws. So we get started by writing the limit as x comma y approaches 2 comma 8, and I always have a hard time with this, of 3x squared times y plus the square root of x times y. Well, the first thing that we're going to say is it looks like the individual limits exist, and this is a sum. We know by the sum rule that we can break this into two limits. So now this is x comma y approaches 2 comma 8 of 3 times x squared times y. And then on the other side, we're going to have that this is the limit as x comma y approaches 2 comma 8 of the square root of x times y. Here, it looks like we're going to have a product and a constant multiple. We could probably bring the constant multiple out and say that this is 3 times, and then I don't know if we want to do at the same time the product. It sounds kind of fun, doesn't it? So here I'm bringing the constant multiple out, and then I say that this is the limit as x comma y approaches 2 comma 8 of x squared. And then my product here would look like bringing the limit in the inside. So this is the product of a limit is equal to the limit of the product. So this is the limit as x comma y goes to 2 comma 8 of y. And then here, remember that x times y square rooted is the same thing as saying x times y to the 1/2. And we saw in the last video by the general power rule that we could actually bring this inside the 1/2, so we can bring the limit inside here. So now this is the limit as x comma y approaches 2 comma 8 of x times y. Things get a little crazy here. There's one thing that we can simplify immediately. Remember that if my function was just y and xy approaches a, b, the output of that is just the value b. So I already know, based on that first set of 3 rules, that this is going to be the number 8, which is what we kind of confirmed earlier. Here we have this is not a pure x. If this was a pure x, the limit, of course, would be 2. But we do have a power, and we saw in the special power rule we can bring the power on the outside. So here we would have this is going to be the limit as x comma y approaches 2 comma 8 of x, and then we're going to square that whole thing. And then I could write each of these ones separately because this is another product rule of limits. where I take the limit as xy approaches 2/8 of x, and then I multiply that by the limit as xy approaches 2/8 of y. That's what we did over here. I'm going to go ahead and skip that step and then just say that the limit as xy approaches 2/8 of x is going to be 2. The limit of xy as xy approaches 2/8 of y is going to be 8. And of course, I've already made sure to track the fact that I need to 1/2 that. We are almost done with this example. The last thing that we're going to do is just finish this limit. Well, remember from the theorem that we had on the last set, and I'm just going to blank this theorem real quick. This was the theorem that we were looking at. If you have a linear function equal to x, then the limit as xy approaches ab of that linear function is just a. So this, of course, would be 2 squared times 8, and then this is plus the square root of 16. And we've already confirmed, this is now the hardest problem that we're going to solve. What is this? 4 times 8 is 32, so this is 96 plus 4, and indeed this limit was 100, which is what our guess was. This is actually a continuous function at that input, and so we could have just immediately gone there had we known what continuity was. But in order to define continuity, we have to define limits. Blah, blah, blah. Okay, it gives you a sense of how to apply this. Claim it's not always this easy, and in fact it's going to get quite beautiful in the next video. The only reason we could apply limit laws blindly is because this, when we input this 2, 8, we stepped on no landmines. Let's find some examples where this thing causes beauties, or should we call them beasts of headaches. Okay, in the next video, that's exactly what we'll do. See you there.